Hello, good morning. Good morning to everyone. Today I came with a new topic, a very interesting topic. Yesterday we had discussed already the introduction of the additive manufacturing. Then what is the advantages, applications, the many things we are discussing in the first class. And today is the second class. This is a very important class. Okay. This second class means whatever the first model already we are discussing in the offline classes, but yeah, anyway, because we are started from the beginning, because many of them are not attending. Okay, for them at least we have to start again from again classes from the beginning. Okay, today I came with a very interesting topic, that is different methods of additive manufacturing. I think in the additive manufacturing, basic concept we clearly understand. The thing is that very important concept it is. So generally there are seven methods are there. Generally there are seven methods are there. The first method is SLA, stereolithography, and second one is LTP, is a liquid thermal polymerization, and third one is FDM, fused deposition modeling, and fourth one is BPM, ballistic particle manufacturing, and fifth one is SLM, selective laser melting, and sixth one is lens, laser engineered net shaping, and fifth one is BJP, binder jet printing. So these all are what I going to discuss, what I mentioned the names, that's we call as a different method for manufacturing, additive manufacturing. But according to the VTU syllabus, they were nowhere mentioned which other topics is going to be discussed. These are they are not mentioned clearly the manufacturing process. But out of this, we are going to be discussing three to four additive manufacturing we are going to discussing. Out of among that four, I came with the first topic is FDM. The FDM full form is very important, fused deposition modeling. Okay, fused deposition modeling. And SLM is selective laser modeling machining, and third one is LOM, laminated object manufacturing, and one more is the direct, yeah, DLMS is there, direct direct laser laser selective laser machining will be there. That these are the four machining processes I'm going to discussing in the coming classes. And today very first means I would like to explain the first method is fuse or deposition modeling. I hope you all clearly understanding, clearly hear my voice, there is no doubt. Then there I would like to start. So in the slide, because I'm taking the class today in the mobile only, because you have to see the screen. Mobile image means whatever the image is there, so I think I hope you clearly appear this image. Okay, I think few things is not captured because while taking the photos, don't worry about that parts of label everything I will be clearly explain it. So first I would like to explain the FDM, fused deposition modeling, how it going to be work, then how it going to be produce the product. Because we know that in the introduction classes we are discussed. Okay, we are discussed. Okay, additive manufacturing is a layer by layer adding material. This is not a material removal process, this is a material adding process. This is a very different process. Okay, what we are going to see from the beginning, whatever from the first semester to up to the seventh semester, these different machining processes, drilling, milling, gear cutter. Okay, lathe machines, NTM, many different machines, machining processes we have learned, we have understanding. We did a laboratory also, means lab also we are having, we did in the lab component also we are going to produce it. But additive manufacturing is totally different from that machines because they are all machine material removal processes. This is a material adding processes, very interesting concept. Okay, it's a slightly means it is totally opposite to the that machine processes. Okay, here what we are doing, how much is needed, that much only we are going to adding the material and producing the component. Very interesting concept. That concept I came with the new concept is, name of the concept is called as FDM, fused deposition modeling. Just you have to observe, just you have to observe the slide. Okay, I would like to explain the component means, it means generally additive manufacturing in the sense you have to keep in mind one computer will be there, it's having a software, 3D software will be there. Then again next up is control unit is there. After that again we have a FDM. Okay, means whatever the FDM is going to be manually we want to fix that. Okay, then control is there. No, this control unit is very important. This control unit is going to be handling the FDM process. Then computer is giving input to the control unit. Whatever you are going to produce in the component, we suppose if you want to produce the any shape of the component, already I have shown in the diagram in the slide. It is like a triangle something. It's a layer is there. So like that component you want, what you will do, you have to in the computer you have to 3D dimensional diagram you have to draw. Then you have to send to the control unit. Then control unit, if any changes are there, you can change it. Then if it is everything is okay as per the dimensions and data, then you have to run it. Then once a control unit is going to be handled, if the manual is ready, then control unit is going to be handle the machining processes. So in the diagram I would like to explain the diagram. So here in the left side you have to come here. So two something thin like structure, wire like structures are there. Okay, parts labeling, I think that is a build material. Okay, it's while taking the screenshot, I think photo, it's not coming in the view. Okay, build material is there, and one more is, I think this is a supportive material. Two materials we are going to use. One is build material and one more is supportive material. Build material is used as a ABS, acrylonitrile butadiene styrene. Please remember it. As a supportive, as a build material, we are going to use the ABS material. What is the long form of ABS? What is the stands for ABS? Acrylonitrile butadiene styrene. This is a one build material going to be used in a FDM, mean fused deposition modeling. And one more material is there that is very important, that is a supportive material, means plastic wax. Whenever you need supportive material, that type of that material, that product only we are going to use supportive material, that is a plastic wax. Not going to use all the component, based on depending upon the size, depending upon the shape. Then when it is, means that's only I'm telling, when it is required, when it is needed, then only we are going to be use the supportive material or plastic wax. Okay, then comes to the next. Okay, you can able to see the round, something round like this, the rollers. Okay, supportive rollers. And again here also rollers are there. That whatever the wire like structure is, material, means supportive material and build material, having a one end is going to be, we are just rolled in, we are going to be stick it there. Then again one end is having a nozzle. In the diagram I clearly mentioned arrow mark, nozzle is there above the roller is there above, and below that nozzle is there. Again the coil, heating coil I mentioned, and again table I mentioned. Even arrow mark up and down arrow mark is shown. Then I mentioned that y-axis. Okay, and below that y-axis in the vertical, x-axis in the horizontal, and z-axis in the inclined, because it is having a x, y and z axis. So 3D modeling means it is going to be produce a component in the three dimensional, x, y, z dimensional. It is going to be, product is going to be producing. This is the things is going to explain. Then again come to the points over here. In the chamber I mentioned that 1 mm something, I mentioned the taken the distance between this from bottom to the upper. Then I mentioned that 1 mm means maximum thickness of the layer. What we are going to adding the material layer for the first iteration, that is going to be maximum thickness of the layer is 1 mm. Then minimum thickness of the layer is going to 0.05 millimeter. Okay, 0.05 millimeter is minimum, 1 millimeter is maximum. So this much of the thickness of the material we are going to be add in the fused deposition modeling. I hope you clearly understand. Okay, once again remember that very important thing is supportive material is there, that is a plastic wax, and build material is there, acrylonitrile butadiene styrene, we called as a ABS. Okay, rollers are there. Okay, nozzle we are going to fix it, and heating coil is there, table is there, and it is going to be moved, table is going to be moved in the vertical direction, or you can call it as a y-axis. Okay, these are the main basic components of the construction of the FDM. Then you comes to the working principle of fused deposition modeling. This is a very important topic. Okay, fused deposition modeling. Okay, so comes to the working. When it is, so this everything is ready. Okay, when this chamber is ready means this is comes in the FDM chamber. In the above diagram is there, see here, computer control unit and so as FDM section is there. That is what I'm going to draw the diagram here below. That is actually FDM. If it is ready manually, what will happen? If the control unit will start the work. Okay, what means if the already computer work is finished, that after that next is going to be sending input to the control unit. Control unit going to be controlling the manually operated things. Okay, what will here going to be fixed? What will happen here? The table is initially it is above the portion of the chamber. Okay, then heating coil nozzle, why we are using everything I will explain, don't worry about that. Then whatever the ABS material is there, that will be comes to, okay, once it started with the help of a roller, it is coming down, coming to the, with help of roller to enter to the nozzle. We know that nozzle means it is having a small section of that. So with the through that nozzle the material will comes down. Okay, so here table, if you want to add the one layer first, initially if you want to add the first layer, so it is like a, whatever the ABS is coming with the help of the, it's like a liquid. Okay, then means it is a solid little bit solid will be there. Okay, that solid I need to make a liquid. Because of that reason I am going to use the heating coil. In the both the side of the nozzle we are going to use the heating coil. It going to be heat, it's going to be converting one phase of the liquid. Means it once it liquid, it will come and deposited easily. Yes or no? So because of that reason we are going to use it. For then what I'm going to show in the diagram, for this material, this component, there is no need wax actually. Okay, wax is no needed because we are one by one we are going to add. When the supportive material as a means, if suppose in the plus like something, okay, like a T section we are going to produce in the that type of produce, what will happen? T having a three whatever the one column is there, then again in the upper portion of that column again one more horizontal column is there. For that the, for a supporting purpose in the left and right side we are going to use as a plastic wax. That is means a supporting material. Means we are going to use plastic wax as a supportive material. Keep in mind, once again I'm telling. Okay, next come to the point. When ABS is coming through the nozzle, means acrylonitrile butadiene styrene material is coming down, what will happen? The table is, okay, it is moving. Initially it was a upper portion. Once it is the one layer is going to be one layer is start depositing, one layer is going to start adding, the what will happen? This table will comes one step down. Okay, one step down means what will happen? These nozzle and heating coils everything will be constant. The only movement of this chamber is that table. I think many of them are getting confusion in the how the material going to be added. Okay, only thing is that very simple concept. Table is movable here. Okay, it is going to be moved in the full vertical direction. Okay, y-axis is going to be covered in the form of a table. Okay, what will happen? According to the as per dimensions, the nozzle whatever the ABS, through the ABS the nozzle through the means through the nozzle the ABS material will come and deposited. So like that this process is similarly, means this process is continuous after the finished product. Okay, that's why I said that this product the plastic wax is no need, because only ABS build material is needed. For that we found that. So what will happen? This process, what means we are not using any unwanted things, any extra things will be not there. So after that the to manufacturing we don't want to need any finishing and because very small number of operations are there after the completion of that. Very, I think you can consider as a negligible, zero extra process after the idea for to manufacturing. So means these products are ready to use, like that you can see it. So very nicely process this additive manufacturing. I hope I discussed the fused deposition modeling. I think you have understand everyone. Are you understanding or not? Understanding. So for your more understanding purpose I make which of all points you can able to understand that working of FDM is very important. There are two different materials. Okay, shortly for your understanding. Okay, for your understanding purpose you will understand very clearly. There are two different material. One is build material, that is in the arrow mark I mentioned that acrylonitrile butadiene styrene. My hand it is not good, no problem, please you have to understand that why I'm going to telling that. Okay, you have to understand, catch my words, and you have to write it. If you want you can write it. Second one is supportive material, that is a plastic wax. Once again I'll repeat. There are two different material. First one is build material, that is acrylonitrile butadiene styrene. Second one is supportive material, that is plastic wax. There are two material wire moves with the help of the supportive roller. Means wire only they are mentioned, because in the diagram you will look like a wire only, because we should not mention wire because it's not a wire. That is a supportive and build materials. Okay, it's if you look like it's a wire, that's what I mentioned, a wire. Okay, you should not write wire. Okay, you have to mention there are two material, one is supportive material and roller material. With the help of the rollers we are start going to be moving the uh, material. Okay, heating coil as well as the nozzle are also using pass the material to the maintaining the heat constant at a chamber. So what we are doing, the why we are using the heating coils, and because we need to maintain the temperature, that because whatever the material is outside the chamber it's going to be solid. I need to deposit, means we have some kind of liquid we need, that's what we are going to use as a heating coil. Then it's going to be deposited. The platform or work table will move in. So platform, I can call it as a two names, either you can mention as a work table or you can call it as a platform also. The platform will move in y direction, means vertically it will be move up and down. Okay, what will happen, that table initially it was the top portion. When the one layer of the metal is going to be add, again it is coming down. Okay, we know that maximum 1 mm of the thickness we are going to be adding. So means according to the how much of the thickness you are going to adding, that much of the table is going to be moving. That going to be before the starting the machining process we are going to fix it that. Okay, so everything what we going to operator they will be do this work. Okay, the table is going to be moving in the vertical direction. Okay, then maximum thickness of the material is adding process is maximum 1 mm. That's only mentioned in the diagram, only previous I said that 0.05 mm to the 1 mm thickness, minimum is 0.05 millimeter to the maximum 1 mm thickness. Then next, depending upon the shape of the specimen and product we will be use the build material and supportive material. Because I said in the previous slide only, because supportive material is we are not used all the time. I said that depending upon shape of the specimen, okay, or product, so we will be going to be used as a supportive material plastic wax. And what after that, one more question comes, if suppose if we are going to produce with the help of the plastic wax as well as the ABS, then how you will remove the plastic wax from the ABS. ABS material is a actually we are demanded material, means I need to produce the product with the help of the ABS material. This is my requirement. So we are using as a supportive material plastic wax. Plastic wax is attached with the ABS material. Then how you will going to be get a separated from the ABS plastic wax? We are going to be use one more technique, that is we are going to be take that product after the producing of the with the help of the supportive as well as the build material, what the component we are going to produce. Okay, that product will take and dip into the HCl, hydrochloric acid. So, okay, that hydrochloric acid solution it going to be react with the plastic wax. Then it is within the short of time it going to be get react with the plastic wax. Then plastic wax is going to be discard are going to be removed from the whatever the ABS material. Then finally the ABS material what the finally from the ABS material what we are going to produce in the product, that is going to be left in the whatever left in the container. That product we call as a additive manufacturing. This additive manufacturing product we are going to be producing with the help of